Hello guys! Can you see the logo up here? It's our Heltec logo. So in the last video we have go to the outside to test our communication test with the Meshtastic, but there was some problem in the first round. We failed to use the European default channel to communicate. So right now I'm going to find the Aaron to ask him the reason why. So let's check in. Professor, are you here? You're free here? So, last time we failed the test in the European default channel 868, right? So, can you tell me some reason why? Because I want now. Maybe the audience also want now.
That's because China CDMA LTE network transmit frequency has effective to EU LoRa band.
Mm-hmm.
Yeah.
So, is that anything I can know it like more specific?
Oh, okay. I will use the spectrum analyzer to tell you why.
Okay, come to check it.
Open it and connect antenna.
Okay.
For EU 868 band, we just need to set the center frequency into 868 MHz, and the span we see to, I think, 40 MHz is enough, and the Y scale, it's negative 30 dBm. Now from the dynamic spectrum, you can see this part is sufficiently higher than other area, right? Now let's keep the value. And here we see two marker, and the marker 1 we set at the right edge of this part here, and the marker 2 we set, yeah, it's at the end of this part. Okay, you can see the marker 1 is 8. Now you can see the marker 1 is close to 870 MHz, and the marker 2 here is 880 MHz. Indeed, this is from the China Unicom LTE CDMA network transmit frequency. But for LoRa communication, for LoRa communication, this is absolutely noise. The LoRa communication in EU 868 and China Unicom CDMA LTE network, they effective each other. And when we clear the marker, now let's back to Meshtastic. We can check from the Meshtastic official document. Here we use non-fast, and the region is EU 868. The default frequency is this. You can see.
Yes.
And here the non-fast, the default bandwidth is 250 kHz. So with some simple calculate, the default it's the center frequency of the default communication point, and here is bandwidth. It's 250 kHz. It's equal to megahertz, right? So the end point of the default communication frequency is this value. 8. This is the default communication. Now we set the marker to the default frequency. It's 869.65 megahertz, and we keep the wave. Look, it's just at the edge of the when the noise began to rise. So That's why. That's the reason I get failure EU band communication in last test. And now let's back to US band. US band, the center frequency is 915 megahertz. Look at here. Look at this wave. It's much lower. The lowest, and we can keep the value. And the lowest for this part is much lower than EU band. So that's the reason why we success in US band communication.
For some 1G, for some 1G IoT network, each country or region have its ruler. That's the reason. Less the effective to other radio frequency signal.
Okay,
Yes.
like different country have their for the user, like for the who use those different frequency to suitable for this.
Yes, of course.
And also, so that's the reason also can make sense why in the nature they have more long distance communication than in the city.
Yes,
Because in
yes.
the nature there are no like the base station or sales cover this stuff. And I hear about one of our user can in the outside they can connect with each other far away, like 20 kilometers this distance.
Yes, that's the reason I had to show you today.
Okay. Well, I think, yeah, good reasons, guys. So right now, do you know why we cannot use the A685? And I'll see you next video. Thanks for Aaron.
Bye.